Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. We are going to continue the last session. We was talking about measurements. Today is the second class of this course, and here today we are going to continue answering the questions about measurements and talk about the rest of the measurements that we didn't finish it last time. Then we are going to talk about density and how we can find the density and answer past paper questions about density and measurements together, okay, from Edexcel and Cambridge and Oxford. Now, as we know that these three boards now they are close to each other. There's small differences between them, but I will explain to manage all details in three of them, inshallah. Good. Okay. Now I want from you, okay, to move with me, لو سمحتوا, to the first measurement that we talk about it, which is time. We talk about the time. We need a watch or stopwatch or digital stopwatch to measure the time in accurate seconds, okay, to be more accurate, okay. And we answer the first question to find the period. Then we talk about the zero error in any instrument, the stopwatch, the meter rule, the ammeter, the voltmeter, the temperature. Always we have to check the zero error on this instrument, the micrometer, screw gauge. Okay. Now let's move on to the multiple choice question that it was your homework. Okay. Question number 3. A student uses a stopwatch to time a runner running around a circular track. The running runs 2 laps, twice around the track. Okay, the diagram shows the reading of the stopwatch when the running starts running at the end of the first and the end of the second lap. Okay, so he starts the stopwatch from 0. The first lap was 1 minute 13 seconds, and the second lap was 2 minutes 3 seconds. What is the time taken for the runner to run the second lap again? So he was running from the beginning, okay, like this until here, this first lap, okay. He finished it in how long? 1 minute 13 seconds. Now the second lap, he started from 1 second 13 seconds, 1 minute 13 seconds, and he go over, okay, until what? Until it's the time, it's 2 minutes 3 seconds. Now we need this time from 1 minute 13 seconds to 2 minutes 3 seconds. Now we know that exactly. Thank you, Tina. Thank you, Saji. Okay, the answer is the difference here. We need to subtract the values from here. Okay, and the answer is what? Bravo. The answer is, thank you. The answer is 50 seconds. Now I told you last time, if you don't know how to do this, you can use your calculator, and there's this is the screen, okay. And here we have the numbers, okay, and somewhere here, okay, we have a bottom. This bottom has a circle, comma, comma, comma. I can use it to to put 0, 0 hour, 2 minutes, comma, 3 seconds, comma, minus, I can use this comma here, okay, minus 0 hour, comma, 1 minute, comma, and 13 seconds, comma, then I write equal. I will get 0 hour, 0 minute, and 50 seconds. This is how it looks like on the screen. Okay, so this is this is our answer. Okay, if you don't know how to subtract 2 minutes 3 seconds from 1 minute 13 seconds, this is how we can do it. Okay, any question? Is it clear? You can't find it? Okay, after the class, send me the picture of your, okay, Mu'taz, on the chat, and I will show you how to do it. Okay, did you find it, Tina? Okay, that's good. Come on. Okay, now, okay, good. Now question number 4. Let me change the color. In question number 4, what they say: 4 athletes run around a track. Okay, the table shows their times at the end of each lap. This is the time for the end of the first lap. This is the total time at the end of the second lap. Which athlete runs the second lap the fastest? The second lap the fastest, that means I need to subtract the time, as I did here, the time between the second with the first. So I need here to subtract minus 22.99. Here I need to subtract minus 23.04. Here the same thing, minus 23.16. Here minus 23.39. And to know which one the fastest, that means I will get what? The least time. The least time as an answer, okay? So the time here, if you have your calculators, you can help me. How much was the time for A? Exactly, for A, the answer was what? 23.96 seconds. Okay, now for B, how much was the time? Send me the chat, yes. I'm sorry. Okay. The time for the first one, A, was 24.05 seconds. The time for the second one was 23.96 seconds. What about the third one here? Yes, 24.02 seconds. And the last one, 23.85 seconds. So the least time for all the athletes is the last one, D. So the correct answer in this situation is D. As you can see, this is a multiple choice question. So since they ask about the fastest, that means he must have what? The least time on the second lap. So the difference between the first and the second lap, okay, it's supposed to be the least, and the answer for the last one, D, has the least time, the difference, okay? So this is how we answer what? This question, okay? Now, there's other questions here, okay? What do we have? Hold on. Okay. Okay, a lot of students we have here, they asked me to be with. Okay, now, question number 5. We did similar to it last time. What do we have here in this question? A student investigate a pendulum, okay, investigate a pendulum, and he want to what? Yes. Okay, he measured the time for the pendulum for 20 complete what? Swings. He repeats the experiment 3 more times. So how many times he did this experiment? 4 times. One original, one value. This is the first one. And repeated 3 times. That means there is 4 times. What is the average period of what? Of the pendulum. Now this is the time for what? This is the time for 20 oscillations. So I need first to find the time, average time for the total 20 oscillations. So T average, okay? And we know that T average is equal the first time plus the second time, okay, plus the third time, okay, plus the fourth time. I put the numbers that I have it here, okay? I put these values, 17.6, 19.8, okay, 17.6 again, 18.6. All of these divide by their number. How many do we have? We have 4. And the answer by using calculator, it will be how much? 18.4 what second. Thank you, Muhammad. Thank you, Duha. Thank you, Tina. Yes, this is the average time. Now, what they ask later, they ask about the period, and we know that the period from last time is equal to the total time or the average time. This answer divide by what? Divide by the number of oscillations, and that answer, it will be 18.4 over the number of oscillations, which is what? Which is 20 what? 20 oscillations. And by doing that, okay, this is not the answer for sure. They ask about the period, the time for 1 oscillation, not 20 oscillations. Okay, how much is the answer? Exactly, the answer is going to be B, 0.92 seconds. So as we can see here, it's 2 steps question, not 1 step. Okay, so so can I add them all and divide them directly by 4 and by what? 20? Yes, you can do that. You can do that, and you will get the same answer, of course. Good question, Muhammad. طيب. Tamam? Is it clear here? Let's move on. What does capital T represent? Capital T represent period, and the small t represent the time, because they ask about the period, the time for 1 complete oscillation. Okay? Good. Any question? Okay, let's move on to next part. Now, we did these questions last time about the time. Now, and we say that we have a lot of questions about measurements. Now we are going to talk about what? About the length. And we said that the length is the how far 2 points from each other, or the distance between 2 points from each other. And we have several equipments to measure this distance. For example, for normal distances, we have the meter rule or the ruler, okay? For long distances, how far is this building from that building? We need to use measuring tape. For short distances, like how much is the thickness of the paper, we are going to use a micrometer, screw gauge, or Vernier caliper. So each equipment, we can use it for different distance. And the main unit of the distance is what? Is meters, okay? Now, also here, we say that in question number 8, tamam, what do we have? The diagram shows the measuring shows a measuring device. For which measurement is this device suitable? This is the micrometer screw gauge, okay? It reads to the nearest 100th of millimeter. 100th of millimeter. That's why they call it micrometer. If we have digital micrometer, it will be a 1/1,000,000th of what? Of the meter, of meter. Yes, 1/1,000,000th of the meter, or 1,000th of millimeter. Can it measure the diameter of the cylinder of aluminum of about 20 centimeter? This is far. It's only with about 7 or 6 or 8 centimeter. That's it. The distance between 2 molecules of zinc, it's too small, the distance between 2 molecules. It cannot be measured by micrometer. It needs a special equipment like electroscope, okay, that with an electron beam gun, okay. Length of the rod of iron, which about 1 meter. It's of course not. Thank you, Muhammad. Thank you, Mu'min. Thank you, Tina. And thank you, Maha. Okay, the answer is D. The thickness of a sheet of copper wire, okay, or sheet of paper, okay, which is what? A thickness of 1.5 millimeters. Yes, that can be measured, and it can be measured accurately. Now, next question is question number 9. They repeated 3 times in the last 20 years. They keep repeating it. This is for Cambridge, okay? And they bring similar idea on for Oxford, but not the same numbers and even not the same picture. What they said here: a cylindrical can is rolled along a ruler, which shown in the diagram here. We have a ruler and we have a can, and it rolls in this direction, in this way as it's shown in the arrow. The can rolls over what? How many times? Twice. The can rolls how many times? Twice. What is the circumference? Even these keywords or these terminologies, they give you what is the meaning of it. Okay, the distance around once. The distance around once. So what is the circumference of the can? That means they ask about the distance from here to here. Now, as you can see, it doesn't start from 0. This is called zero error. Yes, thank you. So it starts from where? From 0, from 2, and rolls once to 13, 15, and rolls twice to what? To 28. So to be more accurate, to find the circumference, which is the total distance, divide by number of rolling times, which is 2. The distance covered is 28 minus what? Minus 2, which is 26. Divide by the number of times that it rolls it twice. So the answer is what? Is A, 13 centimeter. Because it rolls once here, there's rolls twice here. They said that it rolls twice. You have to be careful for each word that they tell us. Okay, and they mention it. They rolls twice. This is the first round from here to here, and this is the second one. Okay, so that's why the answer is not 26. Tamam? So the distance from 2 centimeter to 28 centimeter is the distance to rolls how many times? Twice. They ask for the circumference, not twice the distance. They ask for one distance, one round. So it rolls once here. The mark on the can was here, then it was here the first time, then from here to here second time. So if you measure the distance from here to here, actually from 2 to 15, 15 minus 2, it is 13. To be more accurate, they make check to roll it what? Twice, to measure the total distance until 28, which is 26. 28 minus 2, 26, divided by 2, twice it rolls. So the answer is what? Is 18. Did I answer your question, Mina? This is, yeah, this is for Cambridge. Yes, this question for Cambridge. You can see I wrote the code for each question. Okay. Even if I want to find the distance from here to here, also I can get the correct answer. Thank you, Tina. صح. It's from 15 to 28. 28 minus 15, it's 13 centimeters. Thank you, Tina. Yes, it's correct answer. Tamam? You are welcome. You are welcome. Okay. Last time we did this question, and it was a tricky question. Also, this question they repeated 3 times in the last 20 years for Cambridge. Okay, let's move on to question number 11. In question number 11 here, what do we have? A piece of cotton is measured between 2 points on a ruler. We have ruler, and this is the initial and the final position on the cotton. Who can tell me how much here? How much the distance in the initial position? It's 2.4. Yes, thank you. 2.4 centimeters. What about Dr. Hind الجوبري? Yes, هاي دكتورة physics في مصر، الله يخلي لنا اياها، حابة تحضر عندنا، اهلا وسهلا فيك، تفضلي. Okay, so 2.4 and the final position is 15.6 what centimeter. So from 2.4 centimeter, this is the first position. It didn't start from 0. That's why there is something called zero error. To what? To 15.6. Habiba, put yourself mute. Thank you. Okay. What they ask, when the length of the cotton is wound twice around a pen, it goes how many times? 6 times. What is the distance once around the pen? What is the circumference once? So what we will do exactly to find the circumference, it's to be equal to the distance divided by the number of loops or wings time. Okay, and the distance here, it's 15.6 minus 2.4 divided by what? Divided by the number of times, which is 6 times, and the correct answer, it will be exactly, thank you, 2.2 centimeters. Thank you, Mu'taz, Muhammad, Tina, and Duha, and Muhammad. Okay, I have a lot of people that they give me the correct answer. That's amazing. Thank you. MashaAllah alaikum. Question number 12, we did it last time. Okay, and let's move on to the next topic. Okay, also we answered this question about micrometer. We talk about area, and we have certain shapes that we have to know its area, the formula for it, like a square, like rectangle, triangle, right angle, triangle, trapezium, circle. All these formulas, you have to know it. In math, you have to know more than this. Okay, but in physics, you have to know only this. In some questions in Oxford or in paper 6 Cambridge, they give you some ideas, new ideas with the new areas, and they tell you what is the formula to find the area. So don't worry. Okay, these are the formulas that enough for physics, Cambridge, Edexcel, or Oxford. Okay, and the main unit for area is meter square. Okay, square meter. Question number 14. Doctor, I didn't get number 14. Now we are on number 14. A floor is covered with square tiles. Okay, we have square tiles. Okay, now the diagram shows a ruler on the tiles. How long is one tile? How long is one tile? How long is one tile? It starts from 3 to 9. So the length here is 9 minus 3, which is what? 6 centimeters. Bravo, Huda, bravo, Saif, and Minna, and Muhammad. Yes. So the answer is what? Is B. It's easy. Then what they ask next part? What is the area of the square tiles? Now, since it is square, that means this length is 6, and this width also is what? Is 6. So that means the area is 6 times 6. And the answer, it will be what? 36 squared. Yes, 36 centimeters squared. Or exactly, the answer is B. Bravo عليكم. شكرا يا منا, Muhammad, Huda. I have a lot of names. I can't read them because we have many answers here. Many students, they are amazing. MashaAllah alaikum. Next, question number 60. A decorator wishes, okay, to calculate the area of a bathroom tile. so that he can estimate the amount of adhesive, okay, that he needs to buy. What must he use? Look here, I need to calculate the area. What do I need? Exactly. Do I need a measuring cylinder to measure the volume of the bathroom? No, it measures only the water come out okay, from the tap if you want it. Exactly. Do I need a clock here? Of course not. Even a measuring cylinder. So the only thing that I needed is what? Thank you, صح, bravo. It's ruler. I need a ruler to measure the length, the width. Then I know how much is the area. Then I know how much adhesive I need to buy so to fill it. Okay. Thank you, Muhammad, Mu'min. Okay, Huda, Hani, Lilian. All your answers are correct. Next, we was talking about volume, and this is one of the first thing that we have to know the definitions of it. The definition of the volume. Okay, هلا صار عندنا ما شاء الله 3 معلمين physics حول الوطن العربي بدرسوا اوكي بدون ذكر الدول والاسماء موجودين عندنا بيحضروا قاعدين الشرح تبعي انا it's my honor طبعا ما شاء الله عليكم. Okay, the volume is the space occupied by an object. Okay, so and we know that the volume it's 3 dimensions, so it's supposed to be cubic meter or meter cube. And for regular, we have regular shapes volume, and we have irregular shapes object. We have to know the volume of them. Okay, so for regular volume, usually we have the rectangular block, and the volume of its length times width times height, or the disk or the cylinder, and the volume of this disk or the cylinder is the base area multiplied by the height, or the base area, which is pi r square, because with the mainly it's a circle, so the area of this, the circle is pi r square multiplied by what? By the height, so the volume equal what? Pi r square height. Okay, this is the formulas that we have to know them. Okay, for the IGCSE Physics boards, 3 boards, all of them. But for irregular shape objects, okay, if we have gas, okay, and they ask us to find the volume of the gas, it will be the same volume as the container. If we have a liquid and we need to measure the volume of the liquid, what we will use? We will use a measuring cylinder, and there's rules to use the measuring cylinder. I can't hold it by my hand. I have to put it on what? On a horizontal bench to be vertical. I can't take the reading from it, okay, to avoid parallax error from any position. I have to lower my body and my eye to have, okay, my eye in the same level as the surface of the liquid, okay, to avoid parallax error. Also, I have to take the reading from the base or the bottom of the meniscus. So all liquids, they have a lower their base in meniscus, except mercury, it goes like this. So I'll take the reading from the top of it, okay, which is also the base of the meniscus, okay, the lower or the higher base of the meniscus. Good, clear? Okay, now for solid objects, it depends. If we have a measuring cylinder contains water, I put the object inside, okay, and that the difference in the volume is what is the volume for the object. This is a method. Another method, I can use something called displacement can, okay, or Eureka can. It's a can with a water, okay, with a funnel here, okay, and at the top, and usually we fill it with what? With a water or liquid. And when we put the object inside, okay, the extra water, which is equal to the volume of the object, goes down. We can go put a measuring cylinder here below it and see how much the water goes here, and the volume that I will take the reading of it, it will be the volume of what? Of the stone. Eureka can. Yes, thank you, Sajid. Okay, Eureka can or displacement can. Good. Do you know what's the meaning of Eureka? تعرف تحكي يوناني. Eureka means I found it. Okay. Greek word means I found it. Actually, Eureka, it's a sentence. I found it or I know it. Okay. تمام. Okay. تمام. Good. Now let's move on through the multiple choice questions about volume. Okay, question number 17. The diagram shows a measuring cylinder. This is a measuring cylinder. Which unit would be the most suitable for its scale? What's the unit? Bravo, safe. Yes, another answer. It cannot be square. It cannot be square. And it cannot be millimeter. So it is centimeter what? Cube. So the answer is 16. Yes, thank you, Aya. Okay, be careful, Mu'min. It is not millimeter cube. Millimeter cube, you are going to study another instrument in chemistry, which is not measuring cylinder. Okay. Next question. A scientist needs to determine the volume of a small what? Irregular shaped rock. Small irregular shaped rock. Okay. Sample. Only a ruler and measuring cylinder that has partially filled with water are available. Okay. To determine the volume of the rock. Okay. Which apparatus the scientist will use? Can he use the ruler to measure the length and the width and the height of it? Of course not. So I can't use the rule. So I will use only what? The measuring cylinder. I put it in, merge it, exactly, thank you, Aya, Huda, Tina, and Muhammad, and I will see how much the liquid level goes up, and I will take the reading first, the reading second, then what? Bravo, of course, I will subtract the volumes. Excellent. I have many answers that written here, I know. يعني لو تشوفوا قد ايه في خط الكومنتس عم بيمشي بسرعه. Okay. Number 19. Some water are poured into 4 tubes of different cross-section areas. Which tube contains the largest volume of water? Now, to know the volume, I have to multiply the base area multiplied by the height. So 6 times 10, which is 60. And here, 2 times 20 times 4, which is 80. And here, 3 times 30, which is 90. Bravo. And 2 times 40, which is 80. So which one of these is the greatest volume? Bravo. The greatest volume is C. Now, I can change this question by change this word. Instead of writing largest volume, smallest volume. And the answer will be completely different, right? Thank you, Minna. Thank you, Muhammad. Thank you, Tina. The answer will be A. So we have to be careful. Maybe they don't ask about the volume. Maybe they ask about pressure later on the same picture. Which, if we have the same liquid, which one has the greatest pressure? We didn't study pressure, but later on, the pressure depends on what? Density and height. If they are talking about the same liquid, so they have the same density. So which one has the greatest height or depth? Bravo. Thank you, Tina. Thank you, Muhammad. Thank you, another Muhammad. Okay, Huda. شايفين? So every time they bring the same ideas, same pictures, same logic, physics, and we have to understand these words and logic and sentences. Number 20. Which of the following is not necessarily when using a measuring cylinder to measure the volume of quantity of water? Now, I told you what are the steps that I need to measure the volume of water. This 1, 2, 3 steps. Okay. Now, which one is not necessarily? It's very important to realize that it's not necessarily. Make sure that the vertical cylinder must be vertical. It's supposed to be. Make sure that you are in the same level as the liquid of the surface. Yes, it's supposed to be. The reading of the bottom of the meniscus, except if it was mercury. Yes. Using a large measuring cylinder possible. Larger measuring cylinder possible. Maybe not be accurate, and it's not necessarily. So the correct answer, yes, thank you, Lama, thank you, Minna, and Mu'taz. The correct answer is D. It's not necessarily. Bravo. Number 21 here, what do we have? A student has a measuring cylinder containing water and also has a balance, okay? Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. Either the measuring cylinder containing water or a balance, either. The measuring cylinder contain water only, the balance only, neither, none of them. What do you think? Which one is the correct answer? Bravo. The correct answer is, thank you, Huda, thank you, Tina, thank you, Muhammad, thank you. A lot of correct names. Even if you are wrong, thank you, Saji, thank you, Minna. Okay. The correct answer is B. I need only, because I want to define the volume, so I only need what? Measuring cylinder containing some water. Okay. تمام يا شباب؟ الله يعطيكم العافية. Now, finally, last thing that we talked about it last time was mass. And we said the mass is not as the weight. Weight is something, as we are going to talk about it later on, and mass is how much matter, how much proton, how much electrons, how much atoms, molecules you have inside your object. That's how much is the mass. Okay, and how much is my mass? قد ايه انا عندي bones, قد ايه انا عندي skin, قد ايه عندي muscles, قد ايه عندي belly, قد ايه عندي head. Okay, all these they have molecules. How much matter I have? This is my mass, and the mass of this table doesn't change unless we break the table. The mass doesn't change. My mass changes because I make diet. Okay, but the mass of the object doesn't change. It remains constant. So the amount of matter in an object, which is constant, okay, doesn't change. ماشي? Okay. So we use balance scale, not don't say scale, don't say balance. We use balance scale to measure how much the mass of the object, and the main unit is what? Is kilograms. Okay. Now let's move on through the multiple choice questions here. Which statement about the mass of falling object is correct? A. It decreases as the object falls. يا أحلاها، ما أحلاها من طريقة. خلاص أنا بدي أعمل دايت بضلي أنط وإيش وخلاص. Whenever I fall من the top of building خلاص بروح برج خليفة وبنط. يا سلام. It cannot be decreased. Okay. It is equal to the weight. No, it's not equal to the weight. We are going to study the weight. It is measured by Newton. It's in kilograms, not in newtons. Okay. It stays the same as the object falls. Yes, the correct answer is D. Thank you, Tina, Lema, and Muhammad, and another Muhammad. Oh, wow, a lot of names I have. Thank you. MashaAllah alaikum. Okay, thank you, Mu'min, also. Question number 2. What do we have here? A simple balance has 2 pans, okay, suspended from the ends of the arms of equal length. This is two pan scales, okay. تمام. When it's balanced, and the pointer is exactly at 0, there's no 0 error, okay. That means the mass is on the right and the mass is on the left. It is what? It is the same. What they said: 4 masses in total are placed on one pan, which, okay, with 1 or more on the other pans. Okay, we have 4 readings. We will put 1 or 2 or 3 here, and the rest on the other pan. Okay, and the rest on the other pan. Okay, which combination of masses can be used to balance the pans? Let's check. Can we put here 1 plus 1 plus 5, which can be balanced with 10? No. 1 plus 1 plus 5 is 7. It can't be balanced with 10. So this is not correct. Can we do, for example, 2 plus 5 plus 5, and we put here 10? So this is also not correct. So if we check the others, we can find the correct answer, and it's easy. It doesn't take that much time from you. Yes, bravo, شكرا اللي عم ببعث لي الانسرز. Yes, it is 1 plus 2 plus 2. And the other side, I put 5. So yes, the answer is what? The answer is B. Bravo. Thank you. Okay, 2 plus 5 plus 10 cannot be 10, or even 5 plus 10 cannot be equal to 2 plus 10, 12 and 15. They are not be the same. Okay. So, question number 3. What they tell us here. Diagram 1 shows a sealed plastic bottle containing a hollow glass sphere and a steel ball. Diagram 2 shows the same bottle after it has been what? Shaken. Diagram 3, this one, shows the same bottle after it has been shaken again until the broken glass is in tiny pieces. So then we have steel ball, we have a hollow glass ball. I shake it, okay, it's broken. I keep shaking it until it's small pieces. Okay, the mass of bottle 1 with the containers is what? M1. Here the mass is M2, and here the mass is M3. So here the mass is M1, here the mass is M2, and here the mass is what? M3. Which statement given is correct about the relationship between M1 M2 and M3. Mass of all is the same before and after. Thank you, Tina. Saja said A. Mu'taz says A question mark. Huda, Muhammad, Ismail, Muhammad Dawood. I don't know Muhammad. Okay. Look here. M1 is equal to M2 and it's M2 is equal to M3. This is correct. But it cannot be greater or less. It cannot. No way. If you lose them, if you break an object or separate it into small parts or larger parts, okay, like Lego, that doesn't increase the mass or even decrease it, okay? It happens only for nuclear fission or nuclear fusion, and that's something else. I'm not talking about tiny things here. I'm talking about objects that we can see it, okay? I'm not talking about molecules or atoms here. So the correct answer is what? Is A. Now we will talk about the new measurement things that it's called weight, and the definition of weight is included in all boards. What is the definition of weight? Because the bottle is sealed. Yes, thank you, Huda. Yes. Muhammad said the force acting on the object due to gravity. Bravo, Alek. Tina said that it's equal to mg, mass times gravity. Bravo. Who else? Who else? What's the meaning of weight? Yes, it's the gravitational force pulling the object down caused by the Earth. And whenever we go to another planet, each planet has different, you will feel different weight. But if in the space, far from any planet, deep space, you will feel weightlessness. What the meaning of weightlessness? You feel that you don't have any weight. That doesn't mean that you don't have mass. Your mass remains constant. But the weight, how much force of gravity that pulling you, it will be what? Nothing pull you because you are far from any planet. So it is the gravitational force, pulling the object down. One of the answers from Mu'min, it is the gravitational strength pulling the object down to the surface of the plant or to the center of the plant. Bravo, thank you. And it changes. Here, this one, it's not constant. Change due to what? Due to the planet or due to the gravitational field strength, due to the planet, as we are going to talk about it later when we talk about space, okay? Last topic, آخر block in astrophysics. Okay, this is new for Cambridge, but still in Edexcel and Oxford, and they put it in Oxford a couple of years ago, and Edexcel, it was many years ago. Equipments to be measured the weight. What are the instruments that we need to measure the weight? Bravo, another one, spring scale, okay. I can say balance scale. Balance scale to measure what? To measure mass. Spring scale, what else? Newton meter, bravo, Newton meter, because the unit of the force is a Newton meter. It's a device that we can use it to measure what, we have someone is trying to enter, his name is Mo Salah. I will not accept him, okay? Not because I don't like Mo Salah, I love Muhammad Salah, but I don't want to have his name, okay? Okay, right. Another thing, the main unit of weight is what? Is newtons, okay? So we know that the formula, weight equal mass multiplied by gravity acceleration or gravitational field strength. This is the formula. Tell us that the weight and the mass is not the same thing. Okay, we do a mistake and we ask each one, how much is your weight? But that's not correct. How much is your mass? This is the correct answer in kilograms or in pounds. Okay, قد ايه كتلتك بالعربي؟ بس عمره حد سألك قد ايه كتلتك؟ I don't think so. So the weight here, it's the force in Newton, and the mass here is supposed to be in kilograms, and the gravitational G is the gravity acceleration or the gravitational field strength. And on Earth, in some boards they put 10. Now for Cambridge they change it to be 9.8, like Edexcel and Oxford, 9.8 meters per second square, or 9.8 Newton per kilogram. What that means? Each 1 kilogram on Earth, we need a force 9.8 Newton to hold it. Okay, so the weight of each 1 kilogram object is 9.8, or approximately 10. Okay, so that means this weight changes due to what? Due to the position of the planet. So each planet has different what? Different gravitational field strength. Gravitational field strength. And even moons, they have different gravitational field strength. Like, for example, G in Mars, inshallah لما تروح على Mars, okay, G in Mars equal approximately 3.7. G, the gravitational field strength on the moon, G on the moon, okay, it's approximately 1.6, etc. Okay, so when we calculate in the exam 9.8, yes, 9.8. Okay, for Cambridge is 9.8 now, or for Edexcel and Oxford. Now, sometimes they give you, given that the gravitational acceleration is 10. So if they tell you in Edexcel it's 10, use 10, but it's 9.8. Mister, if the mass is in kilogram and the weight is in Newton, why in all weighing scales the unit? Okay, they call, you say it, they call it weighing scale. Okay, but actually it's kilograms, and they measure the force that you act when on it, when you step on it. That's another thing. Okay, we can discuss it later on after the class. Okay, okay, the gravitational field, the gravitational force is higher when the object is bigger, or vice versa, right? Not bigger, greater mass, heavier. When the object is heavier, the gravitational force on it, it will be the same. It will be bigger, but the gravitational field strength on all of us on Earth is the same. Okay, approximately 9.8. Tamam? Did I answer your question? Okay, good. Question number 4. Okay, and the rest of multiple choice questions, as usual, I give it to my students as what? As a homework. Okay, but I'm going to answer question number 8, this one. What do we have here? An object of mass 15 kilogram on Earth is taken to the moon. Huh? You tell me, does the mass change when you take the 15 kilogram from Earth to moon? Tell me yes or no. Bravo, 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 bravo. All of you said me no. Tell me, I have 15 answers here. Said no. So the mass remains constant. Only the weight changes. Thank you, Huda. Thank you, Tina. So the gravitational field strength on Earth, they tell us, look, how much they tell us? It's 10, not 9.8. So I will use this value, 10 Newton per kilogram. And on the moon is what? 1.6 Newton per kilogram. What are the mass and the weight of the object on the moon? Now, on the moon, the mass remains constant. We say that it doesn't change. Only change what? The weight. So the weight on the moon equal the mass multiplied by the gravity field strength on the moon, so which is equal to 15 multiplied by 1.6, and by using calculator the answer is what? 24. So which one is the correct answer? Bravo, it's what? It's A. Thank you, Huda. Yes, bravo. Good. Tamam. Is it clear? Okay. Bravo. صح. Yes. The rest of the questions are your homework. Okay. I want from you to try to do it. Okay. Tamam. Okay. Now we are going to start a new thing after we finish measurements. Now this topic, every year they bring questions. Okay, question about it in Edexcel and Oxford, and maybe on Cambridge they bring multiple choice question, or they ask about it in paper 4 or paper 6. Okay, the alternative to practical. What is the meaning of density? Density is included in the syllabus, the definition. Thank you. One of the answers mentioned by Tina. Okay, density equal what? Tell me yes on the answer on the chat. Send me the answer. What is the density? The definition of density, divine density. Exactly. Mass per unit volume. Mass per unit volume. عشان to make us understand what's the definition of density more, I remember a riddle, okay, that they told us about it when we was young, and most of you heard about it maybe, because now it's a riddle that known by everyone. Now, if I have 1 kilogram of iron and 1 kilogram of cotton, okay, which one is heavier, 1 kilogram of iron or 1 kilogram of cotton? 1 kilogram of iron or 1 kilogram of cotton? Some of you tell me iron is heavier. Some of you tell me, ha ha ha, both have the same. But yes, exactly. 1 kilogram, 1 kilogram. So they have same mass. But 1 kilogram of iron is this size. 1 kilogram of cotton is approximately this size. So they have different volumes because they have different density. Okay, so 1 kilogram of iron this size, 1 kilogram of water approximately this size, 1 kilogram of cotton approximately this size, 1 kilogram of wood approximately this size. So we are talking about 1 kilogram, 1 kilogram, 1 kilogram, but they have different what? Volumes, because they have different density. The molecules, the structure of the molecules, they are far from each other or close to each other. They make air gaps between them, or there's no air gaps between them. So that's why density, they use a Greek letter or capital T, doesn't matter. Density equal mass over volume. This is the formula for it. Mass over what? Volume. So the density, which is mass over volume, this is the formula for it. Okay? This is what the formula for it. Who can tell me what is the unit of mass? We talk about that now. What's the unit of mass? Yes, kilograms. What's the unit of volume? Bravo, cubic meter. So what will be the unit of density? The unit of density is kilogram per cubic meter. Okay, good. Okay, is there other units for mass and volume and density? Yes, we have. The unit of mass can be in grams, and the unit of volume can be in cubic centimeter. So that means the unit of what? Of density can be grams per what? Centimeter cube. So equipments to be measured the weight. Okay, okay. So I don't know what's this by mistake. Equipment, okay, to measure the weight. There's no equipment to measure the weight. The main unit, I'm sorry, I need to fix it. The main unit of density is what? The main unit of density is what? Exactly, is kilogram per cubic meter. What about the other units? Gram per centimeter cube. Now let me ask you a question, and I want to see who can make a relationship, good relationship in his brain. Okay, which one is bigger? Is gram per cubic centimeter bigger, or kilogram per meter cube is bigger as unit? Yani, can I say which one is bigger or has a greater value? Okay, is it a dinar al-Kuwaiti or a dollar al-Amriki? Okay, which one has greater value, or Emirat dirham or Jneh Masri? Okay, which one has greater value? Okay, actually gram per centimeter cube has greater value than kilogram per centimeter cube. Each one gram per centimeter cube is equal to what? To 1,000 kilogram per meter cube. معقول يا أستاذ؟ Yes. خلينا نتأكد. Bring your calculator. Yeah. I need to convert 1 gram over 1 centimeter cube. I need to convert it to kilogram over what? Cubic meter, right? يلا, huh? You will tell me. To convert from gram to kilogram, I will divide by how much? Bravo, I'll divide by 1,000. صحيح. To convert from 1 centimeter cube to meter cube, I will divide by how much? I'll divide by 100 cube. Use your calculator. Put 1 over 1,000 over 1 over 100 cube, and the answer, it will be how much? what? Exactly, 1,000. That means each 1 gram per centimeter cube equal 1,000 kilogram per meter cube. To understand this in reality, to realize it, what's happening here. Look, this is 1 centimeter cube. 1 centimeter times 1 centimeter times. This is 1 centimeter cube. If I fill it with water, it will be 1 gram. It will be 1 gram. The tank of water on the roof of the building, it's more than 1 meter times 1 meter times 1 meter. It's 2 meters cube or 2.5 meters cube. Let's say I have 1 cubic meter, okay, 1 times 1 times 1, and I fill it with water. It will be 1,000 kilogram. We still talk about the same element, water and water. So here, small size, and there's big size. The value of each 1 gram per centimeter cube is the same value as what? 1,000 kilogram per meter cube. That means this value, the density, it is constant also for each element. Not object, element. For each what? Element. For water, water here on in Jordan, for example, or in Egypt, or in Emirates, or Saudi Arabia, or Oman, have the same density. Even in America, if you are talking about pure water, it have the same density. But if we put some salt on it, okay, it changes density. The same thing for iron, okay? Iron everywhere, it has the same density. Here on planet Earth, on the moon surface, it have the same density. Okay? Tamam? Okay. Now let's move on. How to find the density of a liquid? Who can tell me how can we find the density of a liquid? How we can find the density of a solid? Yes, how we can find the density of liquid? How we can find the density of a solid? Now, to find the density, we need to measure the mass and the volume, right? Right? So let me draw for you what we need to find the density of water. We need what? A measuring cylinder. And this measuring cylinder, I put it above what? A balance scale. And this measuring cylinder is what? Is empty. Okay? Now, if I fill it, the measuring cylinder, the same measuring cylinder with water, if I fill it, the same measuring cylinder with water or with liquid, and I see what will happen to the reading of what? Of the balance scale, the balance scale changed its mass. It was M1, and now becomes heavier, it becomes M2. And the volume here was empty, no volume, but the volume here becomes V, right? So to find the density of this liquid, it will be what? M2, bravo, M2 minus M1 over what? The volume V. They ask question to draw in Edexcel or in Cambridge. They ask you to write explanation how we can do that in Oxford or Edexcel or even in Cambridge. So they ask us to what? To write down the steps, okay, of this. Okay, I want from you next time to do it. I want from you to try to write down how we can do these steps. Okay, by words, by talking. Okay. Thank you, Tina. Thank you, Mu'min also. Yes, bravo. Okay, now how can we do the same thing for solid? What do we need? Now that we have several ways to do that with the solid. Okay, we can measure the mass of the solid separated, then we put it inside a measuring cylinder containing water, and we find the difference in the volume, right? Okay, so Mu'min, one of the answers, not fill the water. Partially filled, not fill, because I don't want to fill it completely. Okay, I need partially filled. Okay, so when I put the object inside, the liquid level would go up, and I would see the V1 and the V2, the difference in the volume. Mashi Mu'min? Don't worry. So I want from you also to do that. Bravo, Alec. I want from you to write it down. Do it. Okay, so what do we need here? I bring measuring cylinder partially filled with water, and when I put the object that has a irregular shape object, okay, I will measure its mass and the volume change before and what after adding it. So I have here M1 and I have here M2, and it was here, this was the volume, okay, it was filled with water here. When I put the stone, it becomes filled with water until here. So this is the stone, for example. Okay, this is the stone, and I need to subtract the volumes, okay, between V1, okay, and V2. So the density, as you told me, bravo, density equal, Saji, yes, thank you. Okay, for mass we use balance scale, yes, bravo. Or we can do it like this, bravo, صح. So M2 minus M1 over what? Exactly, V2 minus V1. So by doing this, we can find the difference in what? In volume and different in mass, and we divide these as a ratio. I'm talking about mass over volume, not volume over mass. Be careful. Density equal mass over volume, not volume over mass. ماشي مينا؟ Okay, ماشي محمد? Okay, don't switch it in the wrong way. طيب, تمام? I want from you to try to do it in words next time. Now we have a lot of multiple choice questions. Okay, as usual, it is homework for next time, and I'll choose one of the questions to answer it, which is question number 3. Let's do it now. I want from all of you to be focused. Okay, what do we have here? I told you, then don't mention any idea or any question without mentioning everything. Tamam? Look here, what do we have? 10 identical steel balls, each of mass 27 grams, are immersed with a measuring cylinder containing what? 20 centimeters of water. The reading of the water level rises to what? To 50 centimeter cube. So this is V1, okay, and this is V2. This is V1, this is V what? 2, and this is the mass for each, okay? Tamam? What is the density of steel? Yes, tell me the answer. Tell me what's the answer. Tina, if with the density of the steel less than the density of water and float, that we'll talk about it later. Yes, we have critical situation. Okay. Thank you, Huda. Thank you, Ali. Bravo. Thank you, Muhammad. Thank you, Dr. Muhammad. MashaAllah. Okay. Thank you, Huda. Thank you, another Muhammad. We have a lot of names. Minna. Thank you, Minna. Okay, Mu'min. Okay. Now we look what's your mistake. 10. How many steel ball do we have here? So the mass not for each, the mass for all. So N multiplied by M divided by what? Divided by V2 minus what? V1. Here I can be more accurate by not adding one piece of iron. I can put a lot of pieces of steel or iron to find the average density. The density of a small piece of iron or steel is the same as the large piece of steel. They have the same what? Density. So the ratio will be the same. So 10 multiplied by 27 over 50 minus 20, and the answer is what? C. If the answer is A, you did a huge mistake. The answer is 0.9, which is less than the water. That means steel float over the water. Does steel balls float over the water? No, it doesn't, unless it is what? Hollow. Thank you. Yes, correct. Bravo, Huda. Bravo, Mu'taz. Thank you. Tamam? No, Mu'taz. If they add only one ball here, the volume will not increase from 20 to 50. The volume will increase from 20 to 23. That's it. Okay? Or 22. Only for one steel ball. Okay? Not the whole total volume. Mashi? It will only move to 23. Tamam? Okay, you have to be careful. The rest of the questions are what? Are homework. Look to the picture. Look. This is amazing. Okay. This is the same idea. We have a special idea. If the object float like a cork, what we will do. We are going to talk about these type of questions next time. Let's move on to question number 10. In question number 10, what do we have? A student places 8 smaller coins, okay, similar coins in a pile, as shown here. 8 coins, 1, 2, 3, 4, 5, 6, 7, 8. She or he put them on a pile above each other like this. The height of the pile of the coins was what, 2.4 centimeters. She measured or he measured and find it's 2.4 centimeters. Calculate the average thickness for one coin. This is better to measure the total distance, then divide if they are identical, identical. This is better to measure this. So what will be the thickness for each? It will be the total thickness divided by their number, and it will be 2.7 divided by 8, and the answer it will be 0.3. What's my mistake? What's your mistake? كثير كتبوا لي 0.3 and it's written centimeter. What's the mistake? Bravo. You have to add 0 here. Why to 0.30? Sometimes you lose a mark on the mark scheme because we have to write the answer 2 or 3 significant figures. Bravo. So the answer is supposed to be 2 or 3 significant figures. So 0.30, not 0.3, and it's written centimeter. Okay. Next, what do we have? Okay. Part B. This figure shows the pile of coins, a measuring cylinder, and a beaker contains some water. Describe how the student can measure the volume of one of the coins using a setup, okay, shown in this figure. Okay, I want from you to try to do it. Also as a homework, I want from you to try to explain, okay, how we can do this question. Okay, ماشي يا شباب? Okay, for next time. Yes. Sir, would we lose mark if we don't use 2, 3 significant figures? Sometimes in the mark scheme, Huda, sometimes the mark scheme they have to write the answer 2, 3 significant figures. Sometimes. Okay, minimum 2, maximum 3. So the mark scheme, we don't know the mark scheme. Okay, we don't see the mark scheme. We see the mark scheme when the results come out. So you have to be generous when you're asked, even in the description. دائما ما تكونوا بخيلين، عادي حط الزيرو، مش هتخسر اي شيء، صح؟ بالعكس يمكن تكسبي علامة. اوكي؟ طيب. Question number 11. What do we have here? A student used a suitable measuring cylinder and a spring balance to find the density of a sample of what stone. And then again, measuring cylinder, we use it to find what volume. Spring balance, we use it to find what the weight. And they ask for what the density, how we can find it out. Okay? Tamam. You are welcome. A. Describe how the measuring cylinder is used and state, that's the first thing. Describe how we can use it. This is the first question. Second question, and state readings are taken to find the density of what? Of the coin. What do we need here? Bravo. I need to, as Mu'taz said, I need to put the measuring cylinder partially filled with water. Okay. I merge the stone gently inside it. Okay. Then what? Then what? Exactly. I subtract the reading of the volume before and after. I remember once, okay, in New English School here in Amman, Jordan, okay, I asked the student to bring measuring cylinder and gently put what? Some stones. I bring them to find the density. They throw it to make the water flies up. They break the measuring cylinder. I don't know why. Some students, when they go to the lab, they do monkey business. I don't know why. So we have to be careful and we have to be gentle. Okay. So, tamam. So what do we have to do? Okay. Pour. Okay. I'll put. Okay. some water in the measuring cylinder. To be partially full and take its volume V1, then merge the stone easily or gently, merge the stone and gently and take the new volume V2. Then what we will do here, bravo, then the volume of the stone is V2 minus V1. The volume of the stone equal V2 minus V1, or the subtraction between the volumes. Clear? Easy? Okay, good. Part B. Describe how the spring balance is used and state the readings that is taken. Now the spring balance, how we can use it to find what? Bravo, to find the weight. Excellent. To find the weight, thank you. To find the weight of what? Of the stone. But I don't want the weight because I want to find the density. So what I need next step? Exactly, I would divide by how much? Divide by gravity acceleration, divide by gravitational field strength, divide by 10 or by 9.8. Excellent. ما شاء الله عليك هدى معتز تينا. Amazing. برافو. في كمان محمد وابصر مين حسين. في ناس كثير جاوبوا بس ما لحقتش اقرا اسمائهم. So by hang the stone by the spring balance to find its weight, then divide it by the gravity acceleration. (9.8) to get the mass. Of the stone. Clear? تمام? You are welcome. C. Write down an equation. Yep, okay. Write down an equation from which the density of the stone can be calculated. Now we know if they ask us to write the equation, we cannot write down in symbols. We have to write it in words, unless they ask in symbols. So in part B again, the spring balance is measure the weight, not the mass. And we need to find the density, which is density equal what? Is equal to what? Mass of the stone, mass, over what? Over volume. So in part A, we find the volume. Now we need to find the mass. So the spring balance, find the weight. We divide this weight by the gravity acceleration, 9.8, to find the mass. And then mass over volume is what the density of the stone. Thank you, Huda. Thank you, Hani. Thank you, Muhammad. Thank you, Minna. Did I answer your question? Okay, good. Next, D. We have a problem here in this question. The student then wishes to find the density of cork. Do you know what's the cork? The cork, it's something like a sponge, okay, but made by certain type of wood, okay, that they close the neck of some bottles, like olive oil bottles or champagne bottles that come out like this, okay? This cork actually, it has low density. It can float over the water surface. So I can't use this technique to find its density. So what do I need to do? I need to tie it with something, make it sink, and inside the water. So the water will rise the volume by both of the sinker and the cork. So that means I need to know how much is the volume of the sinker before I use it, or I tie it with a cork to make it fall down. That's why I can use the stone. This is stone, I can use it as a non-volume sinker. So tie it with non-volume what? Sinker. The stone here, we already find how much is its volume in part A. So we can tie the stone as non-volume sinker with what? With a cork. And we do the experiment. So we can find how much is its volume and its masses, of course. Tamam? Good? Did you get the idea? Is it clear? Thank you, Tina. Thank you, Muhammad. Thank you, Muhammad. Thank you, third Muhammad. Okay. MashaAllah. Allahumma salli ala Sayyidina Muhammad. Okay. Now, question number 12 from Cambridge board. Okay. They ask us to define density, 1 mark. Density, mass per unit volume. It's easy. Okay. Mass per unit volume. Next part, it's a tricky question here. They don't give us usually direct ideas. Look here, what do we have? The density of aluminum, it's what? 2.7 grams per cubic centimeter. They give us the density. Okay? The thickness of rectangular sheets of aluminum varies. Aluminum sheet that we use it to foil, the aluminum foil that we can put it around what our food when we cook it. It has very thickness. Sometimes it's thicker in some places, thin it's in other places, but as an average, it is much less than 1 millimeter. Smaller than one millimeter, much smaller. Okay. A student wishes to find the average thickness. Okay. She obtained the following measurements. She brings a sheet of metal aluminum sheets. Okay. And she measured its mass, 60.7 grams. And she measured its length, 50 centimeter long, and the width, 30 centimeter long. Okay. First of all, calculate the student values from here, from these given m, length, width. Okay. They ask about the volume of the sheet. Now, usually students, they think that volume equal length times width times what? Thickness or height. Do we have the thickness? Yes, Ustad, it's 1 millimeter. No, it is much less than 1 millimeter. We don't know how much it is. It is smaller. So I can't use this weight. It's wrong. So what I will do, Ustad? Bravo. I will use the formula for density. Okay. What is the formula for density? Density equal mass over volume. So I'll do switch multiplication. That means the volume equal what? Mass over density. And I'll put the mass that I have it here, which is 60.7, divide by the density of aluminum, which is 2.7. And my answer, it will be how much? Approximately 22.5. Okay. 3 significant figures, centimeter cube. Good. Tamam. 2 easy marks. Sometimes you have to be clever, or somehow sometimes you have to be notified. You have to notice that they didn't give us the thickness. Okay, I have another way to find out the volume. Now they ask about the thickness. Look here, the average thickness. It's not constant thickness, it's average thickness of this sheet. So we know that the volume, which we just find it out, equal length times width times thickness, T, and the thickness equal volume divided by what? Divided by length multiplied by width. And it will be 22.5 over 50 centimeter times 30 centimeter. Okay. And the answer will be how much? 0.015 centimeter. 0.1 centimeter, it's 1 millimeter. So it's much less than what? 1 millimeter or 0.1 what centimeter. Okay? Tamam? Okay. Now, this is part B of the question. Okay? Now, let's move on to part C of the question. Another student provided with a mean of cutting, okay, the sheet. Okay, he has a scissor or whatever he wants to cut the sheet, decided to find the average thickness using single measurement instrument. That's an instrument, not, I don't need the mass, the length, the width, I don't need these. I'll do that once again, okay, directly once. Assume the surface of the sheets are perfectly smooth. I name the measuring instrument she could use. What is the instrument that I can find the thickness of the aluminum sheet? Bravo, Tina. Bravo, Mu'taz. Another name, huh? Who else? Bravo, Muhammad. Bravo, Rahmi. What else? Micrometer screw gauge. Yes, micrometer. It's one word. Micrometer screw gauge. Okay. Now this micrometer, okay, it's the instrument that I will use it to measure the thickness of the metal sheets. But why they ask that I can cut the sheets? Look here, double R. Describe the procedure she should follow to obtain the accuracy, an accurate value of the average thickness of the metal sheet. Details of how the reading of the instrument is not included. We talked about the instrument last time, how we can use it to take the reading, but now they don't ask about it. They want from us how we can use this instrument to take the reading. What do we need to do? Exactly, I can put not 50, 100 sheets. It's very, 150 sheets is very thick. I can put 10 sheets, okay? I can put 10 sheets, okay, and use the micrometer to measure the thickness. Then I divide by 10, right? Good, type. Why there's 3 marks? I mentioned only 2 informations. Measure the thickness of 10 sheets, then divide by 10. Why there's 3 marks? I told you last time, every time they ask about instruments, how we can use it. First step, I need, bravo, thank you, Tina. I need to check the zero error. First, check the zero error of what? Check the zero error. Then measure the thickness of 10 sheets. Measure the thickness of 10 sheets and divide this thickness by what? Divide this thickness by 10. Okay, there's extra marks sometimes in the mark scheme. there's extra mark. Do not press, do not tight, okay, a lot on what? On the sheets. Thank you, Tina. So what? It will not press it more. And here, because they said details of how we can read the instrument is not required, I can't say anything about parallax error. I can't say anything about parallax error, okay? So, and maybe if I repeat it, okay, and at different positions, okay, and find the average, it will be accepted answer, and repeat it at different positions. And find the average or find the mean, okay, it will be accepted answer in the mark scheme, okay. And I told you here, do not what tight, okay. اوكي في ناس عم بيبعتوا مسجات فعم بشيلها اوكي. And do not tie on the sheets because I pressed them, so it will be small reading. تمام. Good. It's not extra, there is no extra marks, but sometimes on the mark scheme they put extra mark if the student didn't say first check the zero error, sometimes. So I don't know the mark scheme during the exam. During the exam, I don't know. So maybe I put the answer, I put a mark, okay, continue the whole exam, then I return back here to what? To realize that I need to add more details. Because whenever they ask about questions for describe or explain, I have to write everything. Okay, I don't know the mark scheme during the exam. Okay, tamam. Okay, let's move on to next question. Question 13, it's a paper 6 question from Cambridge. And you can see that paper 6 alternative to practical, it's very easy, okay? You need to follow their instructions, okay? Ustaz, if I write extra answer on this, they mentioned 2 other, okay. Now, if you add any extra ideas, okay, but it's not the opposite of your answer, that means it doesn't cancel one of your answers, you will not get extra mark, but maybe you get a full mark, okay? Tamam? What else? What another question? Now, this question, as you can see, it's a long question. It's paper 6 question, alternative to practical for Cambridge. Only we need to follow their instructions. Only we need to follow their instructions. This question, question 14 from Edexcel, okay, also you can find it. It's a lot of parts. They ask a lot of things, okay. Only we need to realize what the question it is. I can send to you here the mark scheme, how they put the marks, what are the extra ideas to get the marks, okay. What are and after all of this, you can find in page 35 and under the rest of the page a self-assessment. You can practice on it and see yourself if you know how to answer this paper and how many marks you will get, okay. Tamam. So let's return back to paper number 6, paper 6 from Cambridge, alternative to practical. They give you all the details. Only you need to follow the instructions. It's a core paper actually, but you have to do it, okay. Or you can do paper 5, the practical paper in the lab. Question 13. A student is determining the density of wood by 2 methods, okay. Method 1 now, method 2 later, okay. He is used the wooden rod shown in this figure. We have this figure. We have a thread, we have a diameter, okay, we have length, okay. Method 1. The dimensions of the wooden rod are shown full size in figure what? 1.2. A. Measure the length L and the diameter D of the wooden rod. Only measure, use your ruler, put it on the paper, put your ruler here. Okay, and tell me how much is the reading from here to here. You can start from 0. Okay, you can start from 0, for example, like this, and tell me how many centimeter is the distance? Tell me, send me on the chat. How much was your reading on the centimeter if you print it out? How many centimeters? Anyone? You can use your ruler now. You don't have a ruler? طيب شو أعمل أنا؟ Look to the question. Measure the length L and the diameter D. The same thing. If I put my ruler like this, to measure the distance from here to here, I measure what? I measure the diameter. Yes. Muhammad tell us it's 4.6. I will follow you. Okay, 4.6. Now I know that you have different printers. So maybe you have different size, plus minus 1 millimeter or 2 millimeters. Okay, but in the externals, all of you will have the same size, exactly the same paper. Like for example, now Tina tell us that it's 4.1 centimeter and Muhammad tell us it's 4.6 centimeter. Now I don't know which one is correct, but you will use the ruler, it's simple, and measure the length from here to here. Okay, what about the diameter, Muhammad or Tina? Now, this type of questions, it has something called error carried forward. So if you did a mistake here and you use it later on, and you continue to use it correctly, you lose a mark here, but you will not lose the marks later. They will accept your answer. Okay? Tamam. Muhammad, tell us how much is what? How much is the diameter? And he did a mistake. Who can tell me what is his mistake, Muhammad? What is your mistake, Muhammad? Bravo. 2 or 3 significant figures. Bravo. So you have to write it 2.0. So now I know the length. I know the diameter. What they ask, 2 marks, easy. Double I. Suggest an accurate method for measuring the diameter of the wooden rod in this experiment. In reality, how can I measure the diameter? It's very hard. List the additional apparatus it might be required briefly. Describe how you could determine the diameter. You may draw if you wish. Do you know what I will do? I put on the bench. This is the bench. Okay. I put the wooden rod here, and I will use 2 yeah, you can say set squares. Okay, like to hold it from both sides, from both edges, and I put the ruler where on the below them. Okay, and I can measure the distance from here to here on the 2 set squares. This is a method to do this. Another method to do this question. Okay, I can bring the rod here, and I can use 2 wooden blocks. Okay, I put 1 wooden block here and another wooden block on the other side to hold it. And I can put my meter rule, okay, my ruler, above them like this and measure the distance from here to here. It's your decision. Okay, the same as the mark MC question, right? Yes, what do you mean by MC? I don't understand your question. Okay. I didn't realize what you want. So multiple choice question. Yeah, similar to the multiple choice question. Thank you. Multiple choice question that we did it here. I told you about. Okay. Here they ask about the inner diameter of the tube. Thank you, Tina. Here in this question, where is it? Here. Yes. I use 2 set squares to measure how much is the external diameter on the ruler. Then what? I subtract the readings. Okay. تمام. الله يعطيك العافية. Bravo عليك يا تينا. Now that's it for today. It's 9:30 Saudi time. Okay. I have another appointment now. Okay, in a few minutes. So that's it for today. I want from you to continue later on. If you have any question, you can stay online. If you don't have a question, you can leave. Assalamu alaikum wa rahmatullahi wa barakatuh. Allah يعطيك العافية.